The second kind of delay we saw was transmission delay. That is the amount of time taking to convert a message into, from the bytes that are sitting in your computer onto the medium like Wi-Fi or Ethernet. Okay? And this depends again on the kind of link we have, whether it's Wi-Fi or Ethernet or fiber optics, but now it's less about like the medium itself and the process of translating into that medium. And different devices, this is what you usually hear about those devices. You hear how fast fiber is or Ethernet in terms of gigabits per second, say. This gigabits per second is about the transmission the time it takes to turn the bytes into things that can travel over the wire. Wi-Fi is on the order of 54 gigabytes, so in the mid-range there for Ethernet. Old dial-up modems, which probably none of you watching this are old enough to remember, but those were a million times slower. Now it depends not only on this time that it takes, that depends on the medium, but also in this case, how big your message is. We didn't worry about the message size for propagation delay because once you start sending light, it goes off and then you can continue sending some light right away and it kind of streams through. But in terms of transmission delay, it's got to transmit everything before it can start transmitting some more stuff. So how much data you're trying to send is relevant to the transmission delay here. Overall, the delay is going to be something like the amount of data you have divided by the rate of sending. So if you're sending a typical kind of message of, let's say, 10,000 bytes, and you're sending it over Wi-Fi, and you do the calculation here, you'll find that it comes out to be something on the order of a millisecond. So much lower than the propagation delay, but if you have a slower kind of device, then significant nevertheless.